Hey there! In this video, we will talk about resonant frequencies in a building and a bridge. Resonant frequencies are basically the natural frequency of both structures. Now, let's say it's a windy day or an earthquake happens. These two things can cause both structures to actually oscillate back and forth. And if this matches the natural frequency of both structures, it can cause them to collapse. But first, we'll go into the subject of buildings. A clip regarding a model will show you how different frequencies impact buildings. During the clip, did you notice as the frequency went higher, the buildings affected went from highest to lowest? So if you're asking if it's safer to be on a taller building or either a shorter one, well, it all depends on the frequency of the earthquake. Now, if you're wondering, how do tall buildings still stand after an earthquake? Well, we have something called damping. What these do are resist, reduce, or either prevent the building from going into oscillation so that it doesn't collapse. Now, I have two short clips and one clip with an interview on how the Tokyo Sky Tree handles earthquakes so well. These clips will show some of the many ways on how we apply damping in buildings.
The world's tallest freestanding broadcast tower and is revealing its secret in overcoming earthquakes in quake-prone Japan. Standing over 630 meters high, Tokyo Sky Tree was designed by Nikken Sekkei, a Japanese architecture firm experienced in building quake-resistant high-rise buildings in Japan. The company developed a system of adding mass as a balancing weight to buildings to control how they sway during an earthquake. For the Tokyo Sky Tree project, the emergency staircase, situated in the core of the tower, acts as the mass, controlling sway during an earthquake. According to Nikken Sekkei, it's the first in the world.
The core column and the surrounding steel frame are constructed separately. Therefore, when it shakes from an earthquake, they will shake in different ways. This system works by utilizing their different ways of shaking to repress the overall sway.
Along the core, oil dampers are also installed to absorb shock. These act as cushions and are able to absorb swaying up to 50%.
で、間のところにはですね、隙間が約1メートルぐらいあるんですけれども、
In the middle, there's a space of about a meter, and from the height of 125 to 375 meters, we put 6 oil dampers. This is to control swaying so that the core column won't hit the inner part of the tower. They also serve to absorb the energy from an earthquake.
Hopefully, the clips gave you a better understanding of how damping systems work. And the reason on why resonant frequencies in buildings are so important are so that when an earthquake occurs, there are fewer casualties from buildings collapsing. Since we've been talking about resonant frequencies in buildings so much, now we're going to go into how it plays a part on bridges. Let's say a strong wind or an earthquake is happening. If either of these two match the natural frequency of a bridge, it can actually cause the bridge to oscillate either transversely or longitudinal. A video by Taylor Devices, which business is to make damping systems for both buildings and bridges, will show one video on how we apply damping systems on a building and two for a bridge.
We depend on them.
They are in our buildings, bridges, towers, even our elevated freeways.
It's available to us and protects us from the unknown, simply and inexpensively.
Taylor Devices is the world's leader in seismic dampers and seismic damping products.
This is what Taylor Devices provides. But that doesn't even begin to explain the level of protection or how these products can help prevent damage to virtually any structure, new or existing. This has a profound effect, impacting communities, people, and businesses worldwide.
Over the waters of the Mackenzie River in Fort Providence, the Decho Bridge has a truly unique use for Taylor lockup devices. This product provides lateral movement during wind loading and thermal expansion, allowing the bridge to float 18 inches. On all but one pier, the dampers will lock up during a seismic event, allowing the piers to act as one to resist earthquake forces. These dampers can withstand stringent environmental conditions such as minus 44 degrees, which are some of the toughest in service.
Taylor Devices provides full analysis, development, manufacturing, and testing capabilities for the world's most challenging structures. They are constantly refining their products and productivity to meet the increasing demands for cost reduction, quality, and earthquake protection for structures throughout the world.
In Vancouver, BC Place Stadium hosts almost 60,000 spectators in one single event. The stadium will not only host over 200 events a year, such as CFL football and Major League Soccer, but will also be used as a regional emergency shelter for events such as an earthquake. Taylor Devices seismic dampers were installed to enable the expansion and upgrade of the new high-tech roof, providing peace of mind as they are extremely reliable, with no dependence on outside energy sources. These upgrades also required no modifications to the foundation and created a seismically safe building.
We have been involved with Taylor Devices in the development and application of viscous damping devices over the last 22 years in this laboratory. Taylor Devices is the leading manufacturer of these devices worldwide, and actually, as far as I know, it's the only manufacturer of these devices worldwide that can manufacture these high-quality, large damping devices.
The Port Mann Bridge is 586 meters that connects Coquitlam to Surrey, BC. Equipped with 146 viscous dampers as part of a seismic protection system when completed, will be the widest long-span steel arch bridge in the world. Compact yet powerful, Taylor Fluid viscous dampers increase structural damping levels to as much as 50% of critical, the results being a truly dramatic stress and deflection reduction.
Located in North Tonawanda, New York, with more than 50 years' experience in the damping business, we offer our customers turnkey solutions to the challenging problems of seismic energy dissipation and structural control, with products which exceed the highest international quality standards.
Taylor Devices products solve challenges and provide solutions.
Solutions that protect us and we depend on.
Products that make the unknown safer.
Well, now, why do we want bridges to stand against earthquakes or high winds? Well, because bridges make travel more efficient. Let's say there's a river. We go over it using a bridge instead of going around it, which saves a lot of time. Now that concludes this video. Thank you for watching and have a nice day.